Hello and welcome to a C API Lua tutorial. So if you want to put Lua in one of your programs, this is the tutorial you should be watching. I'm going to be assuming that you have a basic understanding of how Lua works. You know, you can set functions and you can make tables and print stuff, and that's about it. I'm pretty much basing this tutorial off of the Programming in Lua book. Pretty much chapter 24 to 26. So everything in this tutorial and more is covered in these three chapters. But if you're like me and you don't feel like reading, you can just watch this and I'll pretty much cover the basics. If you ever want to know more, you can just read this book. Highly recommend it. It's only like $30, or you can read it online for free. So the first thing you're going to want to do is download Lua. Now, how do you do that? There's a couple ways you can do it. The first way, if you're on Windows or if you don't know how to use the terminal, you can just go to lua.org and click download, and then look for one of the tar.gz files, download that, put it on your desktop, and then unzip it, and it'll look like this. You just have a bunch of files in here. And if you're using an IDE like Xcode or Eclipse or something, you pretty much just drop all these in your project, and that's the extent of what you need to do. For those terminal people out there, what you basically can do is also do an apt-get install or a brew install, whatever package manager you're using. So I have brew or homebrew, so I do brew install Lua 52, and pretty much installs Lua 5.2 and all the dependencies for it on your machine. It might not be Lua 52 anymore, it might be something else. So you could just do brew search Lua, and then it'll list all the packages that are related to it. You probably want to use whatever's later than 5.2, because that's what I'm going to be covering here. Also, if you're using terminal, the way that you're going to be compiling your program is basically by doing GCC or Clang or whatever you're using, the name of the file, .c, and then you're going to use a linker flag, so you're going to do a -LLUA, and that's basically how you compile it. If you don't use the linker flag, you're going to get a linker error. Yeah, again, highly recommend reading this book. And yeah, so let's get started. You're going to want to, of course, create a Lua file to run off of. So I'm just going to make one called test.lua, and I'm going to make a print statement. I'm going to save it, and now there's one Lua file. So in the C file that you're going to be putting Lua in, there are a couple of things that you're going to want to import, or include rather. That is lua.h and loxlib.h. Now in the program, there are a couple of things that you're going to need to do in order to actually use Lua, and it's pretty simple. There are three things you need to do. You need to initialize the state, you need to load the libraries, and then you need to do file. So initializing the state is just this Lua state L equals Lua L new state. And all this does is it basically loads the interpreter. That's all it does. It doesn't load any of the modules that you would usually expect. So for example, for kv in pairs env do print k. So when you do Lua state, you don't get any of these. So this is basically everything in the global scope, and none of these are loaded. So what you're going to need to do next is load the libraries. So to do that, you just do lua l open libs l. Now, reason why we're creating this L thing and passing it in here is because Lua is written in straight C, so there's no object-oriented design to it. So instead, we're going to be creating this Lua state that we're just going to be passing to every Lua-related function. So the next thing is we're going to want to load the file, and that's just by doing lua l load file l, and the name of the file test.lua. I'm sorry, it's not load file, it's do file. I'll get into load file a bit later. So save that, and you can just compile and run it whatever way you want. So usually in your IDE there's just a little play sign or something like that, but since I'm doing this in the console, I'm just going to do gcc test.c lua, and it compiled. So I'm just going to run the program, and it says hello world. Okay, so that's all well and good. How do you access any of the variables in the Lua file or anything like that? Well, that is also pretty simple. It's pretty straightforward. All you do is do a Lua get global, pass in L, and then the name of the variable. That's it. Next thing you do is, because since C is a static type language and Lua is a dynamic type language, you don't really know what the return type of this is. So what you actually have to do is, after doing get global, you're going to do a Lua to number. So that converts this to a number, L, -1. I'll get into explaining the -1 later. You send this to int. Let's print this out. Print f, the number is %d I. Add a new line here. Save it, compile it, run it, and the number is 0. Now, the reason why it says 0 is because I didn't define it, and 0 is just Lua's way of saying that it does not exist. So how exactly do I check if it exists? Well, basically what you do is you do a little check before to see if it's nil. If you remember, anything that isn't assigned is nil. So L, it's nil. X, nil. Foo, nil. Okay. So by doing that, you do if Lua is nil, L, -1. And you have your print statement. Shit. Oh, what? Oh, I'm sorry. Gotta move the print statement in here too. Alright, A dot out. So see, it says the number is nil. So that's how you check if a number is defined or not. So it doesn't really want to give you errors because people can write faulty programs and you wouldn't really want your application to crash. So that's the way you check if something is nil. Now, let's say you want to run a function, for example. It's basically the same idea. You do get global to get the global, because since everything is basically a variable, even functions. And instead of doing a to number, you actually do this thing called pcall. And it looks like this. Lua pcall L 0 0 0. Pretty straightforward. So let's say foo equals function foo. Compile and run. Sorry, not printf, it's just print. I'm sorry about that. There we go, foo. Now, how do we pass things to this? Well, that's a bit more involved, and I will explain this to you. So, as you've seen before, let's make a new variable x. X equals 5. Now the reason why we do Lua to number L -1 is because all of the variables that are passed from Lua to the C API are actually in a stack. And so to help you visualize this, every time you call getGlobal, you actually are adding the variable foo to the top of this stack. So for example, this is what the stack looks like after calling getGlobal. And I'm going to add a little other one here. Lua getGlobal L X. Or I'm sorry, yeah, X. And then the stack would look like this, foo, and then X. Now basically what the -1 means is that it's the top of the stack. So it's the first one off the top of the stack. So if I put 1 here, it would be foo, very first thing in the stack. But you usually don't want to do this because sometimes there are other things that you don't really anticipate for that are actually called before foo or X are both past the top of the stack. So usually you'd want to go off the top and put a negative number here. Okay, so I'll run this real quick just to help you guys visualize this. So int x equals Lua 2 number, printf number is, or actually x equals %d x. So compile and run. So x equals 5. So it prints foo because I still called it, and then x equals 5 since I printed out the value of x. So back to calling functions with arguments. So the way pcall works is that it actually goes to the very top of the stack and calls whatever function is there. And the way the arguments work is this is the number of arguments you're passing, and this is the number of arguments you're receiving. And then this is just an error function that you could pass in. You know, you could just put null or 0 or whatever you want there if you don't want to call a function if it fails. So like if the function doesn't exist or something like that, or if it's not even a function, you'll know that. So let's say we'll I don't know, square a number. So we'll have one thing to pass in, which is the number we're squaring, and then the result. So let's edit our Lua file to reflect this. Return x times x. Actually, it's just a different variable, so it's not confusing. Okay, so passes in y and returns y squared. So how do I pass something in here? Well, going back to the stack thing, what you want to do actually is pretty much push a number to the top of the stack. So instead of doing getGlobal foo, you're going to want to make your own variable and push it onto the top of the stack. So in order to do this, all you do is do Lua push number L 2. Okay, and that's it. So now, so here you have foo, and then you have foo 2, and then here you have foo 2x. So, I'm sorry. Okay, so this is completely different now. So after doing the pcall, basically what it's doing is it's like, okay, I'm calling a function, top of the stack. Oh, how many arguments are there? Oh, there's 1, so you go back 1. So you basically call this function, and then you pass everything that's after it to the top of the stack as arguments. So after this, it's going to look like something like this, foo to result. And pretty much you do the Lua 2 number for -1 to get the result. So int result equals Lua 2 number L -1. That's it. If you compile and run this, it should be, oh, I'm sorry, I should print this out as well. So printf result is %d result, and a new line. I keep forgetting those new lines. So gcc test.lua, Lua. Oh, awkward. I accidentally compiled the Lua file. Alright, compiled, a.out. Result is 4, x is 5. So x, or 2 squared is 4, so that makes sense, and x is 5. So one more thing I want to do is show you guys how to call C functions from Lua. And by doing that, you're basically going to be pushing a C function to the top of the stack, then setting the global variable, and then that's pretty much it. So let's do some cleanup here. I'm going to delete all this. And by the way, I skipped the video, so if this looks completely different, don't worry about it. I'm going to delete X, delete all this stuff, except for getting the global foo, because we're going to still be calling it. And instead, what we're going to do is we're going to have foo equals function. Say we pass in a string, str, and let's say the function bar, you take a string, and the result is the string and the length of the string. So str len equals bar str. Actually, let's change it to s. S len equals bar str. Then we could print out s and return len. Okay. So what we're going to want to do is create a function called bar that takes one argument and then returns 2 results. So what we're going to want to do is first create the function that we're going to be calling. By doing that, we're going to have to first push the function to the top of the stack and then set the global variable. So all you have to do is do Lua set or push C function L, the state, and then whatever the name of the function is, I'm going to call it L bar. And then you set the global variable, so Lua set global L bar. So that basically takes whatever's at the top of the stack and sets it as the global variable bar. So now, for L bar, you're going to have to implement this. And by doing that, every single C function that's called in Lua is exactly the same. And it has one return type, it's int, L bar, and you pass in a Lua state L. So, way you call this, you still do pushing and popping off the stack. Basically, the arguments are on the top of the stack, and you're going to be pushing the results to the stack. So since there are 2 results, s and len, we're going to be returning 2. So that means we're going to have to be pushing 2 things to the top of the stack. So first we're going to need to set the result to something useful. So const char str equal str equals Lua 2 number L -1. And usually in another language you could just do str length, but I'm in C, so I'm gonna have to do a little hacking around, so bear with me. So while one if char C equals str length, if C equals escape character, then break, and then you do length plus plus. Okay, so now I have the length. So what you're going to want to do is push the 2 results to the top of the stack. So Lua push string L str, or in Lua push number L length. That's it. So that's all you really need to do. Keep in mind, you actually don't need to push this, in my case anyway, because this string is already at the top of the stack. So we could actually just delete this and we do the exact same thing, but just to humor you guys, I'm just going to keep it there. So gcc test.c Lua. Awkward. Bear with me here. Oh, That doesn't make any sense. Oh, I'm sorry. I accidentally put 2 number here. It should have been 2 string. And again. Okay, 9. I forgot to initialize length. Okay. And again, I did not. Oh, I forgot to put a semicolon here. There we go. Alright. So what we're going to be expecting here is, oh, we should actually call this function, huh? So since there is 1 result and 1 argument, we don't need to really do anything except change the argument. So to do that, we're going to have to push a string. So Lua push string L and cheeseburger. So let's recompile this and run it. Ooh, that is not good. So I messed up somehow. I don't know how I did. And I just realized what I did wrong. So what I did is I did a do file, and I set the global foo, and then I called foo before bar was set. So to visualize this, if bar equals nil, then print bar is nil, return nil. So bar is nil. So what I actually have to do is I have to set this C function way before I do any of the other stuff. So right here. So now the C function is set, and when I call foo, it will be defined. There we go. Cheeseburger result is 12. I think this is 12 characters in one. So in order to get tables, let's do that. So let's modify this function a little bit to return a table instead of the length. So instead of just doing 1 call to bar, let's do 2 calls to bar. So local s, or s2 rather, len2 equals bar hamburger. And then we'll create a new table, and then we'll set the attributes of the table. Let's say the key is the string, and then the value is the length of the string. So t s2 equals len2. So this would basically be like t cheeseburger equals whatever the length is, and then t hamburger is whatever the length is of a hamburger. Okay, and then we can just return the table, t. So how do I do this table stuff in Lua? Well, what you do is you first know that the table is now at the top of the stack, so this will not work anymore. It'll just return 0. So you delete that, and what you actually do is to get a value out of a key from a table, you do this. So you push the key. So push string L cheeseburger, and then you do a Lua get table. -2. Now the reason why I do -2 is because, as I said before, table cheeseburger. So cheeseburger's at the top of the stack, so what we need to do is reference table, which is the second thing from the top of the stack. And then it uses cheeseburger as the key. Okay, so now after this is called, we have something that looks like this: table cheeseburger, and then whatever the length is. So all you do is you do a little int result equals Lua 2 number L and -1, since it's on the top of the stack. And so it'll say result is whatever the length of a cheeseburger is. So if you compile and run this, where's GCC? There we go. And then you do a dot out. Result is 12. And we can do the same thing for hamburger. So we can do another Lua push string L hamburger Lua get table L -2 and to result 2 equals Lua to number L -1. And then you know, do this result 2 GCC a.out. Oh, okay, so that's why it tried to get the table from somewhere else. So what we're going to have to do is actually do a pop. So all you basically do is Lua pop 2, because you have the result from the last one and then the argument cheeseburger. So if you compile this, oh, I'm sorry, I passed that as well. Nope, okay, it might be 3. I'm just going to keep trying this until it works. Maybe just 1. There we go. So I actually just have to pop one thing. And that makes sense, actually. It removes cheeseburger and the table off the top of it, or just removes the argument off the top of the stack. So you pop cheeseburger, and then you call it again with hamburger. Okay, so that's cool. How do I add things to the table, for instance? Well, young child, that's pretty simple as well. So all you do is you push 2 things to the top of the stack again. You have to realize that we have to pop the result from the last time off the top. So now the table is at the top of the stack. And what you do is basically you push the key, then the value, and then you do a Lua set table. So Lua push string test Lua push string hello, and then you do Lua set table L -3, since the table is now the 3rd thing from the top. And that's it. You can test and see if whatever it is true. So you can do a Lua push string test Lua get table L -1, and then const char hello equals Lua to string L -1. And that's it. Sorry, this is -2 here. Now this probably won't work. You're probably going to have to do some pops here. I don't know how many I'm going to have to do, but we will find that out. So, a couple compiler errors, no big deal. Too few arguments to Lua push string L test. Sorry. Okay, compile. It probably won't run. Oh, it did, actually. Interesting. So, const char hello is Lua 2 string, so we got to print this out. And then we can do test equals %s, and then we can pass in hello here, and it should say hello. And it does. Awesome. So, yeah. Format this a bit more correctly. And yeah, so result is 12, and then 9, and then test equals hello. So that's how you add things and pop things. I should have went over that a bit earlier, but now you understand it, I hope. Again, you can just keep guessing and checking until you completely understand it. So that's pretty much it. I think that pretty much is everything you need really to get started. If there's any questions you have or clarification, leave a comment so I can annotate the video later, so I can fix stuff, whatever. Yeah, so thanks for watching.